or whatever. Thank you very much. Hope that was useful. I actually had a video, but since I'm way over time, we won't do that. We'll do it for the next time. So thank you.
So let's unravel this elephant, right? What exactly is it? So this is the whole data center architecture, which consists of the network, storage, and the compute components, along with the automation and management. And of course, you have the apps, which are using all of this. Now, the way we have divided this presentation is that I'll be talking about network, because I'm from Cisco, and I'll be talking about the software-defined networking and OpenFlow. And Tulika from Google is going to talk about the applications which control the network and the data center. And Lakshmi Gayatri from VMware will kind of sum it up and say how all this fits in the software-defined data center world. All right, so let's begin with the network. So this is how a sample network looks like, right, today, consisting of multiple routers and switches all over the world. This is the most simplest topology you can find. And what you can see is all the configurations and everything are like hard-coded and preset, predefined. And to make any changes in this topology will be like a nightmare. So given that everything is working today, everything is fine, then why do we need a completely different paradigm for networking? Everything is okay. We are able to connect to the net whenever we want. We can browse the net. We can watch YouTube. Everything seems to be fine. So why change it, right? So let's look at what is changing in the traffic pattern to see why we need a change. So what is changing in the traffic patterns, right? Today, earlier, it would just be hosts trying to reach the internet, which means south to north traffic, and then data getting downloaded from the north to south, from the internet to your host. So this was the whole north-south traffic paradigm. But this is slowly shifting. If you look at Facebook, any update will be connected to a YouTube video, to photos, to updates and everything. And all these are sitting on parallel servers in your data center. What does this mean? This means that all the traffic now is east-west. So this has changed. This is one of the changes that is bringing in this new paradigm shift. The next one is the consumerization of IT. It might not be self-explanatory, because what this means is that you have so many handheld devices, right? And you want to go to work, and you want to be able to connect to the corporate network. You listen to BYOD, right? Everybody wants to bring their device and be connected, whether they are at home, whether they are on the road, whether they are inside the office. And for this, the policies that need to be defined have to change. And they have to be changed as and when the devices come connected to the network. So this is another change that's happening. The other thing is that with the cloud, everything is virtualized, right? You want to set up things and tear down things as and when people want. So this means that you'll have to kind of put together networks and remove away networks as and when the apps want it. So this is the because of the cloud services, your network has to be very flexible to be on and off at any point. And of course, scaling, right? You have big data, a lot of data coming in from everywhere, and you want to be able to scale accordingly. You want to be able to scale for accommodating all this really huge amount of data. So why can't all this be done in the current existing networks? So what are the limitations? So first thing, I showed you that topology, right? Typically, when we get customer calls saying that something doesn't work on my network, we are allowed to log in on the customer box to see why something is not working. So every letter I type on the box, the network administration, say of BT, is sitting and asking me, why are you typing this? Is it going to crash my box? Is my network going to come down? So they're so paranoid about changing even one letter of their config files. They don't want even like a minute or a second of disruption, right? So this leads to configuration becoming static. That means your topology tends to remain as it was over a period of time, because you don't want to touch it. It becomes really hard, because any small change you make, it kind of percolates the whole network. So that's one thing. It leads to static networks. And then because of all the new devices coming into your topology, you need new policies. You need different policies for different things. So imagine a human person, I mean a human, trying to bring in all these policies, managing it. It becomes really hard. The other thing is you can't expect, say you have a really high performance application that suddenly comes in and you want your network to cater to that. So imagine a person, a single human administrator sitting and trying to configure the whole network to accommodate this, right? It becomes very hard. And then the vendor dependence. I shouldn't be saying this coming from being a vendor because now in the topology you need like a new Cisco, you need a new router or a switch. Now it's going to take 3 years, right? You have to wait. You can't, there's no way around it. You have to wait for it to go through its alpha, beta testing, and new protocols coming from the research universities coming into the box and giving it to you. So this vendor dependence is also really takes a lot of time. So these are the limitations of the current network, which doesn't allow you to change as rapidly as the applications want you to. Right, so we think a potential solution for all this is the software-defined networking paradigm. So what is software-defined networking, right? It is an architecture. What does this architecture consist of? This architecture consists of basically, if you look at the topology today, all the hardware network devices that are there today have the control and the data plane in them. So it's completely distributed. Each of the device is controlling itself, talking to each other, building the topology. And if you look at it in some sense, for all of them to understand each other and converge takes an extremely long time. But it happens today, and it's working fine. But with the scale, it is not going to. Now, if you can kind of separate this control plane from the data plane, let the switches and the routers do what they're good at, forwarding, right? And take away this control plane, put it somewhere else. Let it do all the routing protocols, let it do all the complex stuff, and all the policy handling and everything. And then let the routers do what they're good at. And the policies kind of download all the forwarding information, the policies and everything in a format understandable by the hardware devices. One more step to this is that if you can have apps talk to your control plane to say that, do this for me, and the control plane then translates it to the hardware, then it's even more fun. So you could have somebody from the app saying that I want parental control, and that should translate to the policies, to the topologies, and everything should just work seamlessly. So this is the shift in networking, the separation of the data plane, the control plane being somewhere else, manageability being somewhere else, and the apps being able to control the data plane. The control plane. So this is the SDN architecture. Now, how does this solve all the limitations that we talked about, right? We said complexity, if you look at it here, I don't know if I can point. I'm bringing out the limitations in that corner portion. So one we said was complexity leads to status, right? That means all your networks are all statically configured because everybody's scared even to touch one bit of it. But now if your control plane is somewhere else, you have the whole view of the network. You can do all your analysis of what is going to happen if you change something. And then once everything is okay, then download it, and so you're fine. So you know that fear of change is not there anymore because you can, pre-compute, make sure everything is okay, and then download it. So that's one advantage. Inconsistent policies. Now you don't have a human administrator going and changing policies everywhere and then forgetting to do something somewhere, creating loopholes in your firewalls or things like that. So again, your control plane, because it is managed centrally, because of that, your policies become consistent. You can apply your policies end to end and for any application that you need. Inability to scale, now no problem, because you get a new router, you just put it there in the box, the control plane discovers the topology, configures it, and it's up and running. So no issues there at all. And vendor dependence. So here what happens now is you can have your hardware box forwarding it, but your control plane can come up with a new protocol that some research institute had, and then download it. So you don't have to wait for so many years for the vendor company to come up with a new box. Of course, you will have things like 10 gig, 40 gig, 100 gig line cards. The hardware, you will have to wait. That is, inevitable. But at least from the software point of view, from the protocol perspective, it's, everything can be done very quickly. So this is the gentle shift that is happening, right, in the networking paradigm. You had hardware appliances, which you still have, but which is not controlled by themselves, but it is controlled externally through software. I will come to the open part of it, where you have open software or open flow software, which is controlling the hardware devices. We had custom-made FPGAs, network FPGAs which would do forwarding. Now you can have merchant silicon, which will do everything for you. And like I told you, each of the switches had its own control plane, so it was kind of distributed. And now you have one controller, SDN controller it is called, which is centralized management. So again, management becomes very easy. It used to be all, the protocols still exist, but then now what talks to the hardware are the APIs. And you would have function-specific features, but now it's all policy-based, app-based features. The app is dictating what we want to do. And of course, from vendor-controlled to more innovative. So people can think up of new things the network can do and make it do what they want it to do because of the API interface. So these are, I already went through this, but just to summarize, these are the benefits that SDN brings in, right? The centralized management, improved automation, and then rapid innovation, because anybody can come up with this new cool protocols and stuff on the control plane easily through the apps. And then because it is centralized, you can have uniform management in the network. One very, very important thing, which I've already mentioned again, is the applications. The applications can now leverage what is there in the network. So based on what you want your apps to do, you can kind of redesign your whole network. You can just think of it as, you have this network, the hardware devices as your playground. You can just do pretty much what you want. And Tulika will give you examples how Google uses this information to their advantage for their apps. One other thing is that we always kind of get when people talk about SDN, the other word that comes always with it is open flow, right? And there's a confusion about what is open flow and what is SDN, right? SDN is a complete architecture, but open flow is that is a set of protocols that talks between the control layer and a distributed layer, and this is open, like the word says. So it is like a set, like a standards-based API which is given to users, which people can implement on their hardware devices.